All right, so let's get right into it. For our first question, they have us defining the function checkSize that consumes an integer and returns a string indicating its size. Then they go on to specify some additional criteria. If the integer is greater than 50, return toLarge. If it is exactly equal to 30, return perfect. If it is less than 10, return toSmall. Otherwise, return close. So you see they're trying to have us sort of help like guess what the number is going to be. Let me write some test cases to help spell out this behavior. And always an open question is, how many test cases do we need? And you might start by thinking like, oh, well, four conditions, four test cases. But we'll see that it's actually slightly more complicated than that. Let's get our thing set up. We know that we're going to be consuming a integer and producing a string. Um, so let's look at our first case, an integer greater than 50. So how about like 101? Okay, and that produces the string value toLarge. Now let's do another one where it's not greater than 50. How about 50 itself? Which, if we look at the logic here, is not equal to 30. It's not less than 10, therefore it must be close. Moving on, if we have exactly 30, then we have the string value perfect. If we have something that's less than 10, we have toSmall. And then we need something that's in between 10 and 30. So I need, sorry, less than 10. That would have been something like 9. 10 itself would be something that is close. So here I've ended up with 5 different values, 5 different unit tests to try out, because there's sort of this implicit case in between surrounding the 30, like between 10 and 30 and between 30 and 50. That's being handled by the else, the otherwise clause here. And that's pretty tough to see, right? Like that requires some amount of critical thinking to recognize that there is this whole extra case lurking in here. And it can be very tricky to decide how many test cases to have. Usually, the more test cases, the better. And that's a pretty good rule of thumb. So we try defining the function now, checkSize. We know that it consumes an integer. What do we call that integer? Well, we could be very vague and be like, it's an integer or an int. We could also just say it's a value. But the name of the function is checkSize, and the integer therefore is seems to be indicating something about its size. So we could say that it's an int, and it returns a string. As I'm highlighting here, like that's not the only answer. Like there are other good names, but size seems like a good enough choice to me. Now, in terms of the implementation, we can just translate the logic that they give us more or less one-to-one. If size is greater than 50, return toLarge. Or elif, I should say, if size is equal to 30, then return perfect. If size is less than 10, return toSmall. Otherwise, return close. Now, if I run this, I'm going to pass my unit tests. Right? Everything works out fine. And a question that should be on your mind is, okay, if was used here, but I seem to hesitate and I want to say something like elif. If I put in elif, we see that it works too. It doesn't seem to change the result. Now, the actual logic here works out fine either way because we're returning inside of the if statement. Not everyone likes doing that. That can be considered to be bad practice by some folks because having multiple return points confuses what the function does, right? Like we have to look in multiple places and travel through the flow a bit more carefully. Instead, what's often done is we'll assign to a result variable in each of these different paths through the code. And we ultimately end up returning that result variable. So if I run it now, you see I'm still passing all my test cases. And if we watch the flow of this, if we step through into one of the test cases, we'll see that it works out just fine. We ask if the size, which is 101, is greater than 50. It's true. So we do the body of that, result equals toLarge, and we skip over the elifs, right? So we go down directly to the return result. And that's too large, so we just return it. Now, what would have happened if we had ifs instead of elifs with this alternative version where we are assigning to the result instead of returning inside? This time when you run it, you'll see that we're failing certain test cases, particularly this first one. So let me step through and model what happens. We define the function. In our unit test, we call check size 101. We first ask if 101 is greater than 50. And the answer is indeed true, right? So the result equals too large does happen. But then we keep going and ask the other questions. They still get asked because we did not use elif. If we used elif, the first one being true would have caused us to skip the second and third ones. But because we just use if, we continue to ask them also. 101 is not equal to 30, so that's not a problem. And 101 is not less than 10. That's not the problem. The problem comes in what happens with this chunk here. We're saying, okay, well, it's not less than 10, so we must go to the else case, and we assign close. We end up returning close for this entire code chunk because we incorrectly were using if instead of elif in this case. Whether or not you should be using if or elif can be pretty tricky to say, right? It's hard to keep track of when you need which one. But if you think about it critically and whether or not you want the other conditions to be checked, that should help guide you to the answer. So it's corrected now. We're passing all our test cases. Great. Let's move on to the next question. So question 2, define a function is good that returns whether or not a string value is the lowercase word good or the uppercase string good. So again, we'll write some unit tests to help us understand the question better. Assert equal that is good of the string good produces true. If we have the all caps version, that also produces true. If we had this version starting with the capital G, that's not good. That's false because it should either be the lowercase or the uppercase version. And then, of course, if someone passed in something else, like, say, bad, that's also false. So we've got a few different cases here to think about. Now, when we do this one, a lot of people will try and write something like the following. Is good, passing in, it's hard to say what they have other than it's just a value. It's a string value, and it returns a Boolean. They'll write something like if value equals good or good, return true, otherwise return false. And this seems reasonable because it reads like English, right? Like, if value equals good or good, that's what we wrote in the question prompt, we return true or false. If we run this, though, you'd probably be surprised to find out that a few of our test cases are failing, where they're producing true instead of false. And in fact, this function currently as written is always returning true under all circumstances. In order to find out why, we have to step through the code very carefully. So let's step down to one of the failing test cases, launch into the function call. You see that when we get into the body, we ask two questions. The first question is the one we wanted. Is capital G-O-O-D equal to lowercase g-o-o-d? And the answer to that question is false. But then the second question that we ask is not is capital G-O-O-D equal to all caps good, but instead just the string value good. Python is perfectly happy to evaluate a string value using the Boolean operator OR. It's not distributive. It's not saying value equals good. It's saying just is G-O-O-D on its own a true or false value. And there are rules for that. They're called truthiness. In this particular case, a non-empty string is the true value. So it evaluates to good, which is a true value, and returns true, no matter what. So instead of returning, instead of doing value equals good or good, we have to be a bit more explicit and say value equals good or value equals good. And that may feel a little repetitive, but it's just the way that Python's or and operators require to work. They're not distributive like multiplication is in math class. So if you run through it now, all the tests pass. But that doesn't mean that we're done, because this function could actually be dramatically improved. I was saying before that people look at this and they see, whether or not. Okay, that's going to require an if statement. If you have whether or not involved, we're talking about a Boolean situation. Yes or no, true or false, two possible outcomes. That does indicate a Boolean is involved, but it doesn't necessarily mean that we have an if statement involved. Because in this particular example, we're doing some unnecessary work. We ask if this expression is true, and if so, we return the value true. Otherwise, if it was not true, we return the value false. Okay, all well and good, but why go through the trouble of calculating the value true to return true, the literal, when we could just return the calculated value directly? And this may not be comfortable. This may be something that feels a little weird, but it's actually perfectly normal. We're treating the Boolean like a value because that's what it is. Booleans are not special. They're like integers or strings or any other kind of value. They have rules about when they're true and false because they are inherently true or false, but they have operators that work on them, like or and they are values that we can test for. So when we run it this way, it's much shorter, it's much more direct, and it still passes all of our test cases. So it seems to be working just fine. All right, so this one didn't require an if statement. Let's move on to a question that definitely requires an if statement. And this one's pretty tricky. Define a function to Pig Latin that consumes a string value and correctly translates it to Pig Latin. So Pig Latin is kind of a funny thing. It's an English like joke language because it's meant to sort of make fun of Latin itself. The idea is that we're going to be adding AY to the end of words. We're also going to move the first letter of the word to the end before the AY. So if you have something like, let's see, fire, you end up going to Irefay. Now, there's also another rule here. If it's a vowel at the start, like, eat, you don't move the vowel. It just becomes eat a. And that's pretty weird. And then just to make things worse, this question also wants us to match the original capitalization. That's going to be a little bit of an extra tricky step here, trying to make that happen. So here I've got fire becoming Irefay. If I was being careless with my implementation, I'd probably end up with Irefay very easily. So I've started writing some test cases here. Let's formalize that into actual Python code. Always good to start with examples, but it's even better when those examples are actually testable, runnable things. So we'll assert equal. When someone calls to Pig Latin, passing in fire, they end up with the value Irefay. And when they do eat, we get eat a. So let's think about some other cases too. If we had a lowercase version of this word that started with the vowel, so like order, we'd end up with order a. And let's do another one for when it starts with a lowercase consonant, like water, we get otter way. And we're going to add one more case in here, and that's a very basic case of just what happens if we pass in the empty string. And in this case, we'll say that we get back the string, empty string. So those are our test cases. That helps show off what we should be doing. Now we have to actually implement the function. And we start from the top saying, okay, to Pig Latin is a function. It consumes a word, which will be a string type of thing, and it returns a string. Let's define a nice doc string. Always good to get in the habit of writing documentation as we go. So this is a function that consumes a string value and translates to Pig Latin by moving the first letter to the end, unless it's a vowel, and adding AY. And we even leave a note to ourselves, note matches original capitalization. So this probably feels a little redundant, right? Because we already have all that information up here. But remember, in real life, we don't have people writing instructions like this, questions in our code base. We have to put the comments in here because the function is the important part, right? There's no question backing it. And when other programmers come across our function, they want to know what it does and how it works. So we have that doc string in there. Now we can start thinking about the implementation. There's a lot of different ways to structure this. Let's start with sort of the easiest case possible, which is the case where someone passes in an empty string. If someone passes in an empty string, we're just going to return the empty string. And there's a very nice way we can write this in Python using truthiness. So we brought up previously how string values are true if they have anything in them, and otherwise they're false. So you can just ask the question, if not word, return empty string. So if it matches to the empty string, in other words, if it's not got any characters in it, then return the empty string. Otherwise, we're guaranteed at least one character in the string word. And this will be very important because one of the very first things we try and do is move the first letter to the end, right? So we want to be able to have some way of saying like, oh, okay, let's take the very first letter and put it at the end, which requires that we have a first letter. So let's go ahead and get that first letter from the word by doing string indexing. Now, if we didn't have that if not check there, when we passed in the empty string, we would have gotten an index error, right? Because there is no first character to get. But because we've safely checked to see if the word has characters, we're allowed to grab that first one. Now, at that point, we are supposed to put it at the end of the string, but not if it's a vowel. Now, how do we check to see if something is a vowel? There's several ways to do it. One of the easiest ways is just to check to see if the first letter from that word, if the character is in the string value, A, E, I, O, U, either lowercase or uppercase. If it is, then it's a vowel. Now, if that's the case, we're not supposed to do anything with it. We're actually supposed to just return the word unmodified. So word plus AY, right? So that's the eat A case and the order A case. And it naturally retains its capitalization just as it is. So all that's well and good. Now, if it wasn't starting with a vowel, our situation is actually a little more complicated. We'd have to deal with the fact that we've got to move the first letter to the end, and we also have to make it match the original capitalization. And it's that last part that's going to be kind of tricky. So at this point, let's take advantage of our helper function. Let's pretend for a second that we had a magic function that we haven't defined yet called move first to end. And if we pass in a word for that, that magic helper function, we're going to assume that it exists and that it would magically move the first character to the end of the word. Now, if I run this, it doesn't exist, right? And I'll get a name error saying, no, that function does not exist. That's okay, because we can go and write it. And writing that function will be a lot easier than trying to embed all that logic directly in the code, right? Because we already have a lot going on in this function. It's got multiple levels of nested if statements and some complicated logic. And we could do some things to sort of simplify that. We could get rid of this extra variable assignment. Word 0 could replace this. That reduces a line of code. Is that better or worse? Well, it's a little bit less clear what we're trying to ask. We no longer have the nice, oh, is the first letter in the word 0? The advantage of this other structure, though, is we could actually combine all of this into some elifs. Anytime you have an else statement where the next line is an if-else, you can actually combine these to become an elif. They're completely equivalent to each other. So what we had before can be safely replaced by this new code where we restructure everything into an elif and an else. But that doesn't solve the underlying problem, which is I'm referencing this move first to end function that doesn't exist. So we need to go and implement that function. All right, so move first to end. It takes in word, which is a string value. So we'll repeat that, takes in the word. This time it's producing a string that we can concatenate. It's still the same signature as our main function. What does this function do? Let's write out a little docstring. Takes the first character and puts it at the end, matching the capitalization. So this is a much easier problem to solve, right? This is like a simplified version of Topig Latin where we're not worried about it being empty, where we're not worried about the first letter being a vowel. We're assuming that we have a non-empty string of starting with a consonant. Now that makes this a lot easier to tackle, right? We've handled those other cases already. We don't have to think about what happens in them. We just have to think about this unconditional case. So what do we need to do? Well, let's write the most naive version first. We already know how to get the first letter out of the word. We also should remember how to get the rest of the letters by using string subscripting to get everything from the first position onwards, so after the first letter. If we wanted to get the entire string, we could do 1, but of course we want to get everything after that. If we didn't mind, in fact, I'm going to reduce this to make it just rest, first letter and rest, just so it's a bit shorter to type. If we didn't care about capitalization, all we'd need to do is return the rest plus the first, and that would help us. So let me write some test cases to help illustrate what would happen here. Move first to end takes in fire and produces IRF. If we did dad, we'd have add. And if we had banana, we'd end up with Anabi. Now, we're matching the capitalization here. And that means, and then that's all well and good for these simple cases, but let's also remember that we've got cases like good, and that we want it to match ud, lowercase g at the end. So when we have this, we want to be very careful that the new first letter matches whatever the original first letter's version was. So let's deal with that case now. If the first letter is an uppercase letter, notice how I'm testing that. If I make the first letter uppercase, if it's equal to itself, then we know that it was an uppercase letter. If that's so, then the thing that we add to the end of the string value needs to no longer be uppercase. And if the new first letter becomes uppercase. So now we're going to take advantage of another built-in function called title. Title's pretty useful. If we give it a string value, then it makes the first letter capitalized. So if the original first letter was capitalized, this will make the new first letter of rest also capitalized. And then we'll just append our first letter. Now, if we just appended the first letter unmodified, then that's going to cause some amount of issue, where we have banana coming back to be the string value Anna B, and that also capitalized the A. But we probably want it to be lowercase, right? So let's even change this test case over here, banana, to instead be Ananana B. Again, sometimes we want to change the test case. Sometimes we want to change the implementation. We have to think critically, right? Just because I wrote something once doesn't mean it's immutably correct and fixed in stone. We often make mistakes when writing our test cases. We often make mistakes when writing the body. We have to think critically about which one we want to have be correct. But the critical idea here that I'm getting at is if the first letter was uppercase, that's what this expression says, then title case the rest of the letters, aka make the first letter of the rest capital, and append the first letter lowercase. Now, I've written a lot of code here. I just wrote my helper function. If I wrote my helper function correctly, then Pig Latin is done. And we'll know if it works if it passes all the test cases for both the helper function and the original function. And the nice thing about having written test cases for both of those is if these test cases fail over here, then I know that the problem is in move first to end. But if all those pass and I failed any of my test cases over here for to Pig Latin, then I know that move first to end is working just fine. And it's a matter of my logic inside to Pig Latin. Test cases are incredibly valuable. They're one of the best debugging tools that we have available because they help us figure out where our code is broken. So let's try running and we'll see, aha, no, I have an error because I wrote first letter, sorry, over here and then first over here. Let me see if that fixes it. Aha, yes, very good. Very good. And in fact, we're passing all of our test cases. Now, if I had made a mistake here, the test cases for move first to end would let us figure out like, aha, it's not that Pig Latin is broken. Sure, it may be failing some test cases. It's instead more important for us to look at move first to end because its test cases are broken. So again, very valuable taking advantage of our test cases that are available for each of our helper functions.